Dear students, welcome and thank you for tuning in. We are continuing our discussion about cells' interaction with biomaterials as part of the Biomaterials 1 class. In this video, we are going to continue our discussion and we would like to learn about a wound healing scenario. We talked before about the innate and adaptive immune responses, and we would like to get into the details of what happens if we have a cut or a wound in our tissue and what kind of reaction cells will take in that scenario. And then we will discuss in the following video what would happen if we had a cut or an injury and then we implanted a material inside it. How would that differ from a simple wound healing scenario? So we'd like to learn about simple wound healing scenario, how the cells will react in that sense. So cells usually they sense the external environment and they need to communicate with other cells to react and build a collaborative and cooperative responses. So how would cells do this? So cells have receptors on the surface, they are proteins, and we learned about proteins. And one of the things that I would like to note here is that cells differ in two things: their shape. Cell types have different shapes, and also the proteins that they secrete. And when we say proteins, depending on what cell type you're looking at or you're discussing, those secreted proteins or molecules, we call them molecular signals. And if the immune system cells are secreting these proteins, we call those proteins as cytokines. If it's other cell type, we call them growth factors or hormones. So all of them to us are proteins, right? So let's simplify it this way. And in order to have this sensing and communication, in order to build a reaction or a response, I would like to show you this image here. This is a schematic of how would neutrophils, which are immune cells, how would they react if we have a signal that wants or an injury. So just to simplify things, let's assume that this is a bloodstream and this is the wall of your blood vessel, and it's made of endothelial cells. Those neutrophils are in the bloodstream. Now, if we have a damage somewhere here and down, these endothelial cells need to communicate that there is a damage to the immune cells that they are in the bloodstream to pull them out in order to do their job. The signal that these endothelial cells will use is creating proteins and then expressing those proteins on the cell membrane, their membrane. See those purple receptors, we call them receptors. The neutrophils have actually also a set of receptors on their membrane. They are complementary to those receptors. So the first thing we want to say that cells has to sense and then communicate. So cells will communicate by expressing those proteins, and they can sense the environment if there is a matching between two receptors. So the neutrophil, if they come close to the endothelial cells and they see these receptors, the two receptors will attach together because they're complementary, and then this neutrophil will begin to become activated, and then it will move by migration on the surface of this endothelial cell to go outside where the injury is, outside of the bloodstream. It's very important to understand and to realize that cells need to sense, and the sensation comes from the receptors, and the receptors are proteins, and different cells express different receptors depending what kind of cells they want to communicate with, right? So this is, in this example, endothelial cells communicated with neutrophils in order to recruit them to go and to fix or protect an area of the body that has an injury. A schematic that shows us how cells interact, communicate, and sense their environment. Now, for the wound healing scenario, which is the focus of our video, is that what would happen if we have an injury and how cells would react? What is the cascade of actions and reactions that's taking place because of an injury? So the sequence will be like this. If you have an injury, the body will build acute inflammation response, then we'll have a late inflammation response, and then cell will proliferate in order to reconstruct the damaged tissue, and then we'll have remodeling in order to get the tissue to where it was before the damage. So let's assume this is a tissue from the body, and this is the skin. We have an injury. If you have an injury, the blood vessels will be cutted, and the blood will spill out of the blood vessels. Now the blood is made of a lot of cells, and also we have platelets inside the blood, and with those platelets and cells, when they come out of the blood vessel, they will sense different pressure. And what happened for the platelets are they just get ruptured. And you remember that we have also these macrophages and other immune system immune cells. So the first thing that the body wants to do is close the damaged site so that we don't have continuous bleeding, and that happens through coagulation, because the platelets are the primary player in creating coagulation. And that's represented through the fibrin. So we have a lot of fibrin tissue here. So if we have coagulation, the next step is that platelets will erupt, and everything inside these platelets will come out. There's a lot of proteins inside these platelets, and they work as signals, as flags, telling other cells that, well, we have a damaged tissue here, come, and we want to recruit you to heal this location. One of those proteins is platelet-derived growth factor, PDGF, and transforming growth factor beta. And these growth factors actually, what PDGF is a mitogenic growth factor, which means that it's signaling that we have damage, but also it stimulates cells to proliferate. Remember that cells have to get a signal in order to create an action. And we have 4 phases for cells. They either proliferate, migrate, or they differentiate, or they go to apoptosis, which is death. These small proteins from the platelets will trigger the proliferation and the recruitment of these cells. And this is what characterizes the early inflammation. Then the late inflammation, the macrophages will become mature, and then they need to engulf, terminate, and eliminate all the unnecessary damaged tissue, dead cells, or microbes from the site. So they are cleaning up the site. After the late inflammation, cells will start proliferating because of the PDGF, platelet-derived growth factor, in order to reconstruct actually the damaged tissue. Now, proliferation stage, it was going to be a quick stage, and the tissue that is going to be produced because of proliferation is not 100% similar to the previous tissue. So the following stage will be remodeling, which means that we are going to reconstruct and remodel and eliminate and reorganize the tissue and absorb the fibrin, anything that is not necessary, and or excess tissue. The remodeling phase actually dependent on the mechanical properties or the mechanical loads that the tissue is exposed to. So this is a quick overview of what is the wound healing scenario, and we need to understand these stages and what are the cells that plays a role in each stage. If we understand it very well, then we will understand what will happen if we implanted a material that will be present for a long periods of time, and how cells will react and interact. And we need to make sure that the material is compatible versus non-compatible material, what's going to happen. In the coming videos, we're going to discuss what the scenario will look like if you have a material implanted inside the body after the wound been created. Thank you for watching. Until the next video. Bye.